Welcome to all. See, now I am going to close the questions for two connected bodies. Already I solved important questions, but from competitive examination point of view and also academic examinations, such questions are required. See, my purpose, this entire course, engineering mechanics, strength of materials, structure analysis, number one, purpose is structural knowledge for people who want to come up in structural engineering field. But I decided to give equal weightage to academic examinations also, so that it is a systematic and complete course. Now, such what questions I am solving today, say 24, 25, 26, etc. Structural engineering point of view, structural design point of view, they are not required. Because nowhere you get such questions, but they are required for academic examinations and competitive examinations. But one more thing, suppose you are interested only in structural engineering knowledge, spare some time. Spare some time. It won't take much time to solve all these questions. What will happen is, by solving such questions, the concept will become very sharp and clear. So unknowingly for you, you will get more and more grip. See, and knowledge is always something which is always welcome. It is advantageous for you. Even though such applications are not there in structural engineering design field, but concept wise, it will give you very good knowledge. So better everybody study it briefly. Okay, see, question. Two blocks 1 and 2. Last time I told A and B, I am changing to 1 and 2 are connected by a cable. See here, cable, as shown in figure. I written here. As shown in figure. Okay, right. As shown. Okay, as shown means understood. Okay. Placed on connected by a cable and placed on a rough horizontal surface. Then block 1, block 2. Oh, wait, 1 minute, wait. I set the question for 7 kN. If it is 7 kN, see, I want that I set the question so that I can rotate the same question 4-5 times to save the time. I want 0.4 here. 0.4 means 10 kilonewton. That will give 4 kilonewton. Here 0.5 I want 6 kilonewton. Okay, now correct. 1 minute. 6 into 0.5, because actually the 0.5 is the question here. Find mu1. I want round number. I decided to get 0.5. 6 into 0.5 is 3. 10 into 0.4 is 4. 4 plus 3, 7. Yes, correct. Perfectly matching. You never bother all these things. This is for my personal capacity. Your question is weight 6 kilonewton, weight 10 kilonewton. Okay. Coefficient of friction for contact surface of 2. See, not here, this one is 0.4. This contact surface, mu is 0.4. Now, question is, find the coefficient of friction for contact surface of 1. See, here mu is, you can write here, for block 2, mu is 0.4. The question is, what is mu for block 1? Okay. But data given, how you know it? Find coefficient of friction for contact surface of 1. If a horizontal pull, see, horizontal pull means either this way or this way. Horizontal pull of 7 kilonewton applied to the block 2. So they told, see that sketch they are not given. See, they told horizontal pull of 7 kilonewton is applied to block 2 means a force of 7 kN applied here. See, I wrote there. Block 2 results in the system of blocks on the verge of moving. So when you apply a force of, see, pulling force is this way. 7 kilonewton pull this way. The system, the two blocks together, entire system is on the verge of moving. Okay, immediately, I will not tell every time, for all the questions today, you should write, since the system is on the verge of moving, right here, frictional resistance force, FF limit will come, FF limit equal to mu into normal reaction, right here. Let R1 be the normal reaction for block 1, let R2 be the normal reaction for block 2, see, R2, then frictional force. If it is R1, frictional force for this 1, FF1, limiting value is mu1 into R1. So what is mu1? See, let mu1 be coefficient of friction for contact surface of block 1. Let it be mu1 here. Here it is already given how much? 0.4. Now right here. So since you took mu1 here, this frictional force is mu1 into R1. And right here, this contact surface, they told coefficient of friction is 0.4. See, that is mu2. You can write here. See, this is mu2. Here it is mu1. Here it is mu2. I won't write mu2 here. So, or you can write here if you want. In the same sketch, you can write the sketch once again. See here, let it be mu2. Here mu2 equal to, they told, 0.4. And question is, mu1 is how much? What is mu1? Okay. So here, if R2 is normal reaction, frictional force is 0.4 R2. Now, when you apply a force this way, this all you have to write. If you are interested in learning, all you have to write. When you apply a pull this way, the two blocks will move to right side. So frictional forces will be to left side. This is explained thousands of times. Okay. Let T be tension in the cable. Why I mark tension this way, I will not explain because it is told very crystal clear in earlier class. Important concept of tension and compression as required for engineering mechanics. Study that one little earlier, about 7-8 class earlier. Okay, over. Now write this sketch. Now see. Total unknowns are how much? See here. R1 first unknown, mu1 second unknown, T third unknown, R2 fourth unknown. This is not unknown because 0.4 R2. 4 unknowns are allowed because if you consider the entire system equilibrium, you cannot solve. But we are considering part by part. We are considering once first equilibrium of one of the blocks and then second block. For each block, two conditions. Sigma m is not applicable here. See, sigma m will come later. Sigma fx 0, sigma fy 0. I won't waste time every class. See, somewhere right here, this is xx, this is yy, you have to write. Okay. Sigma fx 0, sigma fy 0. So, two conditions here, two conditions there. So, 4 unknown matches. Therefore, see, R1, R2, tension, only one more unknown possible, mu1 is the unknown. Okay, now, write, consider, you write here, statement, see, consider equilibrium of, you should write, consider equilibrium of each block separately. I told repeatedly earlier, separately. Okay, right, first, consider equilibrium sufficient, EQ means equilibrium of block, which one first? See, which one first? See here, block 1, R1, mu1 and T. 3 unknowns are there, no. And whereas block 2, R2 and T, oh, 2 unknowns. So, where less number of unknown is there, consider that block first. So, block 2 first. Why block 2 first? I explained earlier and today once again to write it. Okay, now start, sketch. Block 2, now I won't waste time now. See, consider block 2 here. Weight acting down, how much weight? This weight is 6 kilonewton. This weight is 10 kilonewton. Okay. Therefore, this weight acting down of 10 kilonewton and normal reaction, I slightly shift this side. Why I told you? Otherwise, no problem. R2, then one frictional force here of FF2 limit equal to 0.4 R2 or 0.4 R2, and see, when you consider block 2, see, cover here, see this one only, this tension, see, tension is like this, tension in the string T. Now apply sigma fy0 and sigma fx0. I will dictate here sigma fy0 r2 minus 10 equal to 0. I will not write because this is told so many times. If people tell he is not writing anything, means don't come to my class. If you cannot do that much work, means what I can do? Plus r2 minus 10 equal to 0, r2 equal to 10. Sigma fx0 minus t, sorry, there's one force here. Oh, see? I was wondering what happened there. 7 kilonewton. See, I got a shock. Minus t minus 0.4 r2 plus 7 equal to 0. Substitute r2 equal to 10. You get the tension T. You should take as exercise here. 10 into 0.4 is how much? 4. T will come 3 kilonewton plus 3 kilonewton. It will come. You solve it. Okay, then that's over. 3 correct? 10 into 0.4 is 4 kilonewton. No. 10 into 0.4 is 3 kilonewton, correct? It will come 3 kilonewton. Okay. 3 kilonewton. Here how much it will come? Okay, let's see. Then, now consider equilibrium of block 1. Now consider equilibrium of block 1. See, put the block here. Show the block. One weight down of 6 kilonewton. I told exercise question, then 6 kilonewton. A normal reaction R1 and frictional force FF1. FF1 limit equal to mu1 into R1. And also, if you want to take a right here, this is block 2, this is block 1. Okay. And also, tension T is acting here. See, this tension. And by this time, you know the tension, how much? 3 kilonewton. Again apply sigma fy0 and sigma fx0. You will get the value of mu1. Mu1 will come. Exercise for you, mu1. See, I will dictate. R1, sigma fy0, R1 minus 6 equal to 0. R1 minus 6 equal to 0. R1 will come 3 kilonewton. Okay. 6 kilonewton. You should solve it. R1 will come 6 kilonewton. Then sigma fx0 minus mu1 R1 plus 3 equal to 0. Substitute R1 equal to how much? R1 equal to, where is R1? 6 kilonewton. So, what happens now? Minus mu1 into 6 plus 3, 0. So, mu1, take that side. It is 3 divided by 6. You will get 0.5. I set the question for 0.5, round number. Okay. So, therefore, final answer is, see, I told you, these all systematic way. I wrote so many. This is a question number 24. 23 questions I wrote equations. If you cannot, suppose someone will comment, he is directly giving answer. First of all, I should not solve. Give the question and answer. But I am helping you so that you can solve. What all I dictate, you write here. Therefore, write final answer. Coefficient of friction for the contact surface of block 1 with this horizontal plane is 0.5 is question number 24. Now, I will go for question number 25. Okay. What I will do is, two blocks 1 and 2 are connected by a cable and placed on a rough horizontal surface as shown. Okay, then. See, correct the question, new question. coefficient of friction for contact surface of block 1. This all for concept. Block 1 with this surface is 0.5. That is the answer we got. 0.5. Find coefficient of friction for contact surface of 2. Why I am doing same question? Because answer should tally. If a horizontal pull of 7 kN applied to the block 2 only. Block 2 results in the system of blocks on the verge of moving. So once again, a horizontal pull of, shall I take it left side? No. Okay, let it be that side. Okay, let it be the same question. Okay, same question. Now write all the statement and then see here. Let T be the tension in the cable and mu2 be coefficient of friction for surface of block 2. And therefore, this is mu2 into R2. This is R2. This is tension 7, same. But here, FF1 is not mu, right here. FF1 is here. Mu1, they told 0.5. Mu2, now you know the answer. Last time, your mu2 was 0.4. Same question, mu1 came 0.5. Now mu1 is 0.5. Mu2 has to come 0.4. But new question, see here. This is 0.5. Why 0.5? Given in the question, 0.5 into R1. Write all this. Now, consider equilibrium of which block first. See here, once again. Block 1, R1, 1 unknown, then and T. See here, R1 and T, block 1. But block 2, R2, 1 unknown, mu2, second unknown, and T. Oh, this time, last time, this block has how many unknowns? 3 unknowns. Last time, this mu was unknown. Last question, in 24, 3 unknowns for this block, 2 unknowns for this block. So we consider block 2 first. But this time, unknowns are for block 1, only 2 unknowns. So you consider first block 1. Block 1. Weight is 6 kilonewton. Normal reaction R1. Frictional force FF1. You should not do this way. Is 0.5 R1. And block 1, if you consider a tension T here, this way. Don't see that side. I am changing it now. Get the tension T. See, apply sigma Fx0 and sigma Fy0. I will dictate sigma Fy0 plus R1 minus 6 equal to 0. R1 will come how much? 6 kilonewton. Then sigma Fx0 minus 0.5 R1 plus T equal to 0. Substitute R1 equal to 6 kilonewton. T will again come 3 kilonewton. Okay. Now, consider you should take independent question. Equilibrium of block 2 now. Block 2. Then, see, weight is 10 kilonewton. This is not there. Okay. And this force is there. How much? 7 kilonewton. And there is a tension here, T, but this T is known for you. How much? 3 kilonewton. Unknowns are R2 and FF2 limit is mu2 into R2. So in the question you are right, let mu2 be the coefficient. Okay. Same, I change it. Now apply sigma Fy0, sigma Fx0. I will dictate sigma Fy0, see, plus R2 minus 10 equal to 0. R2 will come 10 kilonewton. R2 will come 10. Then sigma Fx0 minus 3 plus 7, see, minus 3 plus 7 minus mu2 into R2 equal to 0. R2 you got 10. So minus 3 plus 7 is plus 4. Plus 4 minus 10 into mu2 equal to 0. your mu2 will come, not mu1, mu2 will come now. Mu2 will come 0.4. 0.4, right? So second question, I change the question. There any correction is required? I think no, I should be careful. Sometime what happens is, when I take the same question and change the pattern of the question, somewhere, see, maybe I forgot right here. Old one is there. At that time, change it. That much work for you. I think nothing is there. Everything is okay. I'll check once again. Block 1, 6 R1, 0.5 R1, 10 R2, 3, 7. Correct. So answer. Therefore, coefficient of friction for the contact surface of block 2 with that horizontal plane is 0.4 is the answer. Now question number 26. See, what I am doing is now I write the question and change it. See, two blocks 1 and 2 are connected by a rod, not cable now, by a rod. Now one thing is guaranteed. Why I am putting a rod? Because now I am not going to pull it, I am going to push it. See, when you put a cable and pull it, cable will be in tension. But when you put a cable here and push any of the block, cable cannot take tension. It can take only compression. See, if you put this also, I told you. See, when push comes, see, when you push, it gets compressed. Cable cannot take compression. Therefore, I will put a rod here. What is there? This is the rod. See, this is the rod. Connected by a rod and placed on a rough horizontal surface. Now, as shown. Okay. Now, what I will do is, I will take this. See, this is 6 kilonewton, and see, coefficient of friction for contact surface of 1 and 2 are respectively, how much I told? 0.5 and 0.4. That is, I want the same answer. Then 0.5 and 0.4. Okay. Okay, for both surfaces. Then find weight of block 2. Weight of block 2 if a horizontal push of 7 kilonewton is applied to block, which one? Block 2 only, block 1 I will make, to block 1. But system will again move right side. Okay, I will put to apply to block 2 only, because I want to change it, block 2. Okay. If a horizontal push of 7 kilonewton applied to block 2 results in the system of blocks on the verge of moving. Okay. 1 minute. Okay. So the question is, you write here if you want. See, once you write all this, one more sketch you write. There you write here. This mu is, how much I told? 0.5. This mu is 0.4. And this is the rod. And they told horizontal push means either this way. See, block 2, push means this way. Horizontal push of 7 kilonewton is applied. So now the system of blocks will move to left side. So let not T, what you write? Let C be compression force in the rod. See, I told compression is always like this, thousands of times I told. Then this is 6 kilonewton, this is R1, right here, FF1 limit equal to mu1 is 0.5, 0.5 into R1. And here, this is not 10 kilonewton, they want to find it. See, this weight you call W2. So question is, let W2 be They want what? WB weight of block 2. Block 2. They want to find what? See the question here. Find weight of block 2 if a horizontal push of 7 kN applied to block 2 results in a system of blocks on the verge of moving. Okay. So let it be W2. Okay. Now, horizontal push they told, therefore see, you take independent question. This is 7 kilonewton. Okay. Now see, now make a note. When you push this way, this rod will be in compression and system will move to left side. Since the system moves to left side, frictional force will be to right side. This I told thousands of times. See, the contact frictional forces will be to right side. See, last time it is pulled right side, friction was left side. Now it is pushed to left side, friction is to right side. Make all this note. Then anything over 1 minute now. Plate on the rough horizontal surface as shown. This is 6 kilonewton. That weight is not known. Coefficient for bonded surface of 1 and 2 are respectively 0.5 and 0.4. Find weight of block 2. Okay, correct. Now 6. Now see. Now what will happen is the normal reaction will slightly shift to left side. Why means I told the reason, but actually you don't bother about it. R2. So here also, okay, now this much you write first. Then consider equilibrium of each block separately. 1 minute, let me check the recording. Everything is okay? Yes. Considering equilibrium of each block separately, question comes, which block first? Start. This block has unknowns, see, R1 and C, 2 unknowns to block 1. And this block R2, it is not mu R2. How much mu I told? I told mu 0.4 equal to 0.4 R2. Okay. R2, then compression C and weight W2. Oh, this time 3 unknowns are for block 2, but only 2 unknown for block 1. So once again consider first equilibrium of block 1. So 6 down, R1 slightly this side, but actually don't bother. If you got enough knowledge, you take care of it. R1 and frictional force is to right side. See here. Frictional force is right side. How much? 0.5 R1. Okay. Apply sigma Fy0, sigma Fx0. You will get the compression. See, you will get the compression C. See, I'll read slowly now. Right. Oh, sorry, not tension. Compression. Okay. Sometimes it happens. I think I'll take care. So start. Plus R1 minus 6 equal to 0. R1 equal to 6 kilonewton. Then sigma Fx0 minus C plus 0.5 R1 equal to 0. Substitute R1 equal to 6. C will come 3 kilonewton. Okay, then now consider equilibrium of block 2. When you consider block 2, the weight is unknown, W2. W2 is unknown. So now this is your R2. This is R2 and frictional force is to right side. See, frictional force is right side, not mu to R2, 0.4 R2. See, these corrections you should not make it. You should solve systematically. If you want to understand everything, solve systematically. Okay. Now right here. Everything correct? W2, R2, sorry, see, forgot. 7 kilonewton. See, again, sometimes I should be careful. Compression C, which is known for you, C equal to 3 kilonewton. Okay. This is also over. Now apply. I write here now if you want sigma Fy0 first. See what happens. Plus R2 minus W2 equal to 0. So your R2 will come equal to W2. Call equation number 1. Okay, then sigma fx0. Right side positive. What do you get? 0.4 R2, 0.4 R2 here, plus 3 minus 7 equal to 0. Substitute R 0.4 R2 plus 3 minus 7 equal to 0. But your R2 equal to R, but see here, substitute 1, that is R2 equal to W2. What do you get? 0.4 into R2 is W2. W2 plus 3 minus 7 equal to 0. 3 minus 7 is 3. So you get 0.4 W2 equal to 3 minus 7 is, see 3 minus 7 is minus 4. That side is plus 4. So W2 will come, your W2 will come 4 by 0.4 is 10 kilonewton. Yes, because we know the answer that this question is set for 10 kilonewton there. Okay, W2 is 10 kilonewton. Okay. Now let me check it first. Any correction required later I should not regret. 7 compression, okay. Then 6 W2, push this way, friction this way, normal reaction, block 1, 6 down, R1, FF1, C, W2, R2, 3, this 3 and 7. Okay, question number 26 over. Now last question for today, 27. 27. Okay, now again I will change the question. You should do independently, don't do like this. 2 blocks 1 and 2 are connected by a rod once again and placed on a rough horizontal surface as shown. Now I write here weight equal to 10 kilonewton. This I am not writing, see. And then coefficient, it's a sketch, given sketch. This is not given, okay. Coefficient of friction for contact surface of 1 and 2 are 0.5 and 0.4. Find the weight of block 1 if a horizontal push of 7 kN is applied to block 1. Block 1 results in the system of applied to block 1 results in the system of blocks on the verge of moving. Okay, solve now. First see, they told what? Horizontal push of 7 kilonewton to block 1. So now they are applying here. How much it is? So push means this way. Horizontal push means here. See here, block 1 they are giving. If you apply this way, it becomes pull. This is not there. Okay. Right. Let C be the compression force and let W1 be the weight of the block 1. Okay. Weight of the block 1. Now, 1 minute. I should change the pattern here slightly. Okay, now everything correct? Now important here. You are applying push this way. System will move to right side. So friction will be to left side. Left side. This all, you should write all this. Frictional force left side. Here. Right here. Frictional force equal to 0.5 R1. Let R1 be normal reaction. Here, frictional force equal to 0.4 R2. R1, R2 are the normal reaction, 6 and W2. Okay. Consider equilibrium of each block separately. Which one first? See here. Block 1, unknowns. R1, one unknown. This is not unknown. C. Second one, C. Oh, sorry. Which one? Find the weight of block 1. Okay, no. W1. This is how much? See, I forgot. This is 10 kilonewton. This is W1. Okay. Now you know the answer. Answer will come 6 kilonewton. Okay, now see. Because weight of block B given. See here. Weight of block given. Weight of block 1, you find the, where is it? Find the weight of block 1 they want. Okay, now. See, let the weight be W1. Let W1 be the weight of block 1. Now, see, block 1 unknowns. R1, one unknown. W1, second unknown. And C, 3 unknowns are there. But block 2, R2 and C, This is not unknown. So this time you have more unknowns for block 1, 3 unknowns, 2 unknown for block 2. Therefore, you consider equilibrium of block 2 first. Okay, write once again. Okay. To save the time. This time consider first. See, this all important concept. Consider equilibrium of block 2. Okay, start. Block 2. Weight of 10 kilonewton. Normal reaction R2. Moving which side now? Moving this side. Okay, friction force. Moving that side, no? So I should shift R1 slightly that side. Okay, no problem. You don't bother about it. Because I do not want to make mistake. R2. Okay. Weight, which one first? Block 2 first. See, you are considering block 2 first. Okay. Weight 10 down. Then normal reaction pushing that side. R2. Frictional force of how much? This side. FF limit for block 2 is 0.4 R2. 0.4 R2 and also a compression force C. Now make sigma Fy0. R2 minus 10 equal to 0, your R2 will come 10 kilonewton. Sigma Fx0 plus C minus 0.4 R2 equal to 0. This is plus C plus C. Substitute R2 equal 10 kilonewton. 10 into 0.4, how much? R2 is 10. 10 into, oh, something wrong there. Just a minute. 10, R2 is 10. 10 into 0.4 is, yes, 10 into 0.4 is 0.4. This is not C. See, when you consider C is calculated, C, you will get compression C. What happens now? C minus 0.4 into how much R2? 10 equal to 0. So your C will come this time 4 kilonewton. Correct, 4 kilonewton? 1 minute. 10 kilonewton. How it came 4 kilonewton? If I apply 7, just a minute. C is 0.4. R2 is 10. 10 correct? Yes. 10 into 0.4 is 4 kilonewton. C minus 4. Last time C came 3 kilonewton. Oh, because I applied force here. Okay, okay. C may change, but remember, final answer will not change. Just a minute. I'll check once again. R1, 7 kilonewton compression. C, 10. I'm considering this block. So, minus 10, R2 minus 10 equal to 0. So, R2 will come 10 kilonewton, correct? R2 will come 10 kilonewton. Then, if I apply force there, then to come 3. Then sigma Fx0, we get plus C minus 0.4 R2 equal to 0. Substitute R2 10, your C will come plus 4 kilonewton. Okay, plus 4 kilonewton. Okay, no problem. Because the push applied is here. Now consider, right here, consider, see, this is somewhat exercise type. You should solve it. Equilibrium of block 1. When you take block 1, see here, what happens? Weight W1. Weight W1. Then normal reaction pushes this side. No, it is pushing that side. See, normal reaction R1. Weight W1, normal R1. Frictional force this way of FF limit for block 1 equal to 0.5 R1. R1 and next one compression force is there. See, a compression force here. See, this block, compression force C of how much? 4 kilonewton. Already you got it. Okay. Now, anything else? Block 1, W1 down, R1 up, FF limit here, temperature. Sigma Fy0, take upward positive. What you get? Plus R1 minus W1 equal to 0. Therefore, R1 equal to W1. Equation is not required. Sigma Fx0. Right side positive. Minus 4. See, minus 4. What is missing here? So, oh, there is a force of 7 kilonewton here. Oh, see, I am getting a shock of my life. Getting shock of my life. Okay. Minus 4. See, when you consider block 1, 7 kilonewton, minus 4 plus 7 minus 4 plus 7 minus 0.5 R1 equal to 0. Substitute R1 equal to how much? W1. What you get? Then minus 4 plus 7 is plus 3 minus 0.5 into R1 is W1 is 0. Therefore, you get the value of W1, weight of block A. 3 divided by 0.5 is exactly 6 kilonewton, correct? There is a reason why that compression changed from 3 to 4. I won't explain now, because if I keep on telling those things all, some people find difficulty. Suddenly, first I thought 3 will come, then I decide, oh, force applied from this side. Therefore, reason is there. I know the reason. Okay, now, over. W1 is 6 kilonewton. Question number 24, 25, 27. Now, do one thing. Lastly, one question, 28. Beautiful. This is once again the old question. See, to close all these questions, see, two blocks 1 and 2 are connected by a cable. Okay, once again, cable. Cable. This way. Please, on a rough surface. Then, coefficient of friction for contact surface of 1 and 2 are respectively 0.5 and 0.4. Okay. Now, not find. See, question is find. No, I change the question. Weight already given. Here in the question, weight is given. See, weight equal to how much it is? 6 kilonewton. New question. It's a cable now. See, two blocks you should not mix up. You should, as I solve, observe, then copy what I wrote here. Don't see previous solutions. Two blocks 1 and 2 are connected by a cable and placed on a rough horizontal surface as shown. Weight of this is 6 kilonewton, 10 kilonewton. This is not given in the question. See, coefficient of friction for 1 and 2 are 0.5, 0.4. So you can write if you want later. See, this mu is 0.5, this mu is 0.4. And question is find the least pull required to be applied least horizontal pull required to be applied to block 1 so that the system is on the verge of moving. Okay, start. Let T be tension force. T be tension in the cable. Okay. And let P be least horizontal pull to be applied to which one? Block 1 to block 1 right here, so that system is on the verge of moving. You write all this one. Okay, now right here, least pull they want. So see, for one least pull means this way, P. Now you know the answer, P how much? 7 kilonewton. Okay, this is not W1, this is 6 kilonewton, this is 10 kilonewton. This is R1 pulling this side, So reaction will slightly shift this side now. Okay. R1 and R2. This is all, you don't bother. Let it be there only, R2. Now you are pushing this way. So system is moving to left side. Frictional force will be to right side. Here also, frictional force will be to right side. See? Right side. Those who are serious, you should write everything. Coefficient of friction here is 0.5. Let R1 be the normal reaction. So frictional force limit equal to mu into R1 equal to 0.5 R1 FF2. See, now pulling this way, this is not this is tension. See, I will forget it. Now it's in what? Now it's in tension. Tension T. Okay. Now pull P here. FF correct now. 6 down, 10 down. P friction, 6 R1, 10 R2. Okay, done. So first consider equilibrium of which block first? See now, if you consider block 1, unknowns are R1, P and T, 3 unknowns. If you consider block 2, unknowns are R2 and T, therefore first block 2. When you take block 2, weight is 10, then we are pulling this way, R2 is upward, friction is to right side, see, friction is to right side, FF2, 0.4 R2, and this is tension in the cable T. Happily solve and get tension. See, I will dictate here, plus R2 minus 10 equal to 0, your R2 will come 10 kilonewton. Then sigma Fx0 plus 0.4 R2 minus T equal to 0. See here, plus minus T plus 0.4 R2 equal to 0. Substitute R2 equal 10. 10 into 0.4 is 4. Tension will come 4 kilonewton. Okay. Then, now consider equilibrium of block 1. Weight is 6 kilonewton. This I will remove. Weight is 6 kilonewton. Normal reaction is R1. Which one I am doing? 2. R2. This is 2. I am doing which one? This one, 6 kilonewton. See, 6 1. Normal reaction R1. See, block 1. And there is a tension here. See, here. Tension T equal to 4 kilonewton. And here, there is a force P which is required to be found out. Okay, this is same. R1, 0.5 R1 over. Everything is ready. 1 minute now. I'll check once again. If any mistake is there. 1, 2, 6, 10, 0.5, 0.4 given. Find least pull applied for block 1. Okay. Block 2. R2, 10. T, friction. Pulling this way, friction that side. Okay. 4. Correct. Now see. By chance, if there is anything is not changed by mistake, which is actually reverse, some changes are there, you change it. That much effort you should put it. Okay, start. Sigma Fy0 plus R1 minus 6 equal to 0, your R1 will come 6 kilonewton. Sigma Fx0, see, sigma Fx0, right side positive, minus P, see, minus 0.5 R1 minus P, something wrong here, 1 minute, P here, minus P minus 0.5 R1 and then plus 4 equal to 0. How much R1? Something wrong here, 1 minute. Minus P T. Oh, see, I can make out something wrong. See there. I forgot to change the friction. See, because I am not getting 7 kilonewton. This question originally it was 7. Same 7 has to come. You know answer. See, I forgot to change it. Okay, see. Okay, now sigma Fx0 minus P plus how much? 0.5 times R2, 0.5 times R1, 0.5 R1 plus 4 equal to 0, or see, substitute R1 equal to 6 kilonewton minus P plus 6 into 0.5 is 3 plus 4 equal to 0. So P equal to 7 kilonewton. So I rotated the same question 5 times. One question I asked mu given for one of the blocks mu given, find mu for other block. Next question, other block mu given, so you interchange. If last time for 1 given, this time for 2 given. Okay, then next I gave one of the weights and find other weight. So first I don't know which one I given. If W1 given, W2 you have to find. Next question, W2 given, W1 you have to find. Last question is traditional question. Everything is given. Find the least value of P when system is on the verge of moving. Okay, these all questions over. Now, sufficient, I will close now. Next, one more class I require. Just one more class I require for connected bodies, two connected bodies placed on horizontal plane. Remember there, one question I will do one thing. I will ask you find mu here and find mu here. It cannot be solved. Unknowns are more. So I will not give mu for any contact surface, but I will tell in the question mu is same for both. If I will tell in the class what will happen by chance if the person who said the question, if he asks you find mu here and mu here, nobody in the world can solve it. I will tell that one. Then I will tell, oh, the question is wrong. The person who said the question does not have too much basic knowledge. Actually, I only said the question deliberately. So he should either give one of the mu and find other mu. Okay, that is all today. Or if both the mu's you require, he should tell both mu's are equal, or he should tell the ratio of the mu's. See, you should tell this mu and this mu should be have ratio. You should tell this mu is 20% more than that mu, etc. They should see mu1, mu2 both cannot be unknowns. It should be single unknown. Either they should tell both has got same mu, or if they want different mu, he has to give the relation between the two mu's. Then next class, one very interesting question is there. Beautiful question next time on that body. So that all I will do in the next class. Okay, thank you. Next class we will meet.